Hello everyone, welcome to Tector.com. In this lecture, we will just solve a problem and we will check for this given relation or the functional dependencies, what is the maximum possible normal form it satisfies. So to check, we will start with first NF. So what is the first NF condition? That all the values will be atomic. So we are considering that the values will be atomic. So it will be in first NF. Now we have to check for second NF. To check for second NF, what is the condition? The condition is that all the non-prime attributes should be fully functional dependent on each candidate key. So here we have to find out candidate keys for this relationship first. So let's find out the candidate key. The candidate key for this particular relation is AB. So now let's find out what is the non-prime attribute. So very simple, the attributes which are not present in this key. So it will be C, D, E, P and G. Fine. Now we have to check whether each of the non-prime attribute is fully functional dependent on each of the candidate key. Here we have only one candidate key, AB. So we will check whether these attributes are fully functional dependent on AB. So let's start with checking C. Here if we check C, C is fully functional dependent and we will keep on checking, but very simple method is that let's see whether one of the A or B, which is prime attribute, determining something which is non-prime attribute. So here we can see from these functional dependencies, what we will do, we will search that whether one of this prime attribute determining a attribute which is non-prime. Okay, so alone we have to say we have to see one of this. Okay, not altogether. So if you check, we can directly come to this point and we will say that here B is determining G. Okay, so this B alone is determining G, where G is a non-prime attribute. It means this non-prime attribute G is partially functional dependent on candidate key. Okay, so we can say that this is not in 2NF. So the highest normal form this relationship is satisfying here is only 1NF, that is, it is in first normal form. So this was a question which was asked in GATE 2008. Now let's extend this problem and let's decompose this relation so that it satisfies 2NF. So we have studied what we will do. We will just write this relation R1 and R2, and the functional dependency which is creating problem to be satisfied for 2NF, we will separate this. So we will keep B and G here, while we will keep the remaining elements including the determinant of this functional dependency in this relation. So A, B, C, D, E and P will come here. Now here it will be B determines G, and here all the remaining functional dependencies, that is AB determines CD, DE determines P, then C determines E and P determines C. Fine. Now this will be in second NF for sure. Okay, because we have already eliminated the violating condition. Okay, the violating functional dependency we have already removed. Now let's check whether it is in 3NF. So what is the criteria for a relation to be satisfied 3NF? So the criteria is there should not be any transitive dependency or any dependency between non-prime attributes. So here the candidate key will again be for this relationship. What will be here? This is already in 3NF now because there is only two attribute and only one functional dependency. So this will be in 3NF, even in BCNF. Okay, even in 4NF. Fine. Now let's check for this. So here candidate key will be again AB. Non-prime attribute for this relation will be the attributes except AB, that is C, D, E and P. Now let's see whether there is a relationship between CD and EP. Okay, I mean between these four. So yes, we have, this is C and P, which is non-prime attribute. This is C and E, this is again non-prime attribute. Okay, here DE determines P, so DE again determines P, so this is also one of the violating condition, right? And this is AB determines CD. So AB determines CD is perfectly okay, because here AB is a prime, A and B is prime attribute and it is determining something. Fine. So we have three violating functional dependencies. So what do? We will separate all these three in multiple tables. So here we will have three tables, that is R3, R4, R5 and R6, and what we are doing is we are just, for each functional dependency we are creating separate table. Now a question is like whether these R4, R5, R6 and R3 are in third normal form. So of course yes, because there is only one functional dependency and here AB will be the key, only one functional dependency and D will be the key, similarly C and F, so it will be 4 and F and even B, C and F. One important question may arise here is that why we are separating this into four tables. Is it possible that we just separate this ABCD in one table and in these in different table, and then we proceed? Like, is there any possibility that rather than 4 we can have less number of decomposed table, that is maybe 2, maybe 3 tables? So the answer is yes, we may have, but we just for the simplicity I'm just resolving or decomposing this table into multiple tables based on these functional dependencies. But what you can do is you can keep two tables, one is AB which will contain ABCD and another one is DC, and these all, like one is this one and another one for this one. So we have two tables. Now this one is all, this one will be in BCNF, that is third normal form, and BCNF, and now you will apply the same check for this table which will be resulted. Okay, so this table again you will check starting from this first normal form, second normal form and so on. So again, whenever it doesn't satisfy the criteria for next higher level normal form, you break this depending upon the functional dependency. Okay, and then you can proceed. So in this manner you may get tables less than this number of 4 tables, that is 4 table here and 1 table initially which we divided for second normal form. Fine. So you may get less number of tables. So I hope this question is clear, but our question was already solved. Our question was that whether this functional dependency is in second normal form or not. I mean, what is the highest normal form for this given relation. So it was first NF only, and now we further we extended this problem and we understood that how we can proceed further to decompose the tables. So I hope you understand it. If you have any related doubt, please go ahead and ask your question in doubt section. Thanks for watching.